is to remind you that a week from today is the math retreat, which is a day in which all math classes are canceled. I also won't be having my office hour because I'll be doing other things all day. If you really want to talk to me on Monday about something, then we can push up that meeting till Tuesday. I can make time on Tuesday. There are a bunch of talks going on. Have people taken a look at the math retreat schedule yet? Have people found the math retreat schedule as posted on Canvas? No, okay, well, maybe I'll find it the way that's quicker, or I'll pull up the course webpage. I think I added it. So there's the course webpage. Oh no, I still have it. Okay, it's in Canvas. Why am I still logged in? I should have had to log in, right? So it will be posted in an appropriate extra credit. Attend a talk during the math retreat and come talk to me about it. There is a link to the schedule for the math retreat. Go look at that schedule. I know that you should be available during the 9 o'clock hour. And there are some talks during the 9 o'clock hour. They're sorted first by like who's speaking during those times, but if you scroll down, there are the talks that happen during the 9 o'clock hour. Take a look at some of them. And then come talk to me. I'm not expecting like you understand everything that happened. Just put in the effort to pay attention. Tell me what you got out of it. Neato. All right. There is also a math retreat competition also happening on that day. During the 3:30 hour, I think is what the schedule says. Double check that because I can't be trusted with the schedule. I'm the one who made that schedule, but I can't be trusted with the schedule. Any people interested in participating in that with the note that that is probably the lowest effort way to get some extra credit points? Okay. You can talk to each other, talk to anyone you want, try to sign up a team, shoot me an email, I'll get you signed up. If you don't have a team in mind, shoot me an email saying you're going to be a free agent, I'll put you in a team. Nice. All right. Cool. So before I start in, any other just logistical questions about stuff? Yeah.
Do you think we'll get our exams back on Wednesday?
Yes. With the exception of 4 exams that didn't find their way home with me for the weekend, they're all graded. So if you want to come by my office hour at 1 o'clock today, I can tell you what you got. Ideally, I'll have them posted to Canvas before that, but my morning gets kind of crazy. So if grades aren't posted by the end of today, then I'll be very annoyed with myself. And if you want to know soon, I'll come by my office hour. Nice. All right. Let's talk about what I want to talk about today. So the first thing to talk about is we have 2 inverse trig functions right now. We have inverse sine and inverse cosine. And how did we get those? We looked at the graph of sine and cosine. We said, well, those aren't one-to-one, so I can't even invert them. So we can restrict domain. How much of the domain can we use? Use that much of the domain. Now we have a one-to-one function, invert it. And now, like, treating that like an inverse function will always be a little bit subtle. Like if you want to solve an equation, you'll lose some information. But then you can use that. Just keep track of what information you lost. Let's do the exact same thing for sine. Well, nope, tangent. So let's start with that. What's the graph of tangent look like? So let's start with this. What's the tangent of 0? 0, right? If you start at an angle of 0, what's the slope of that thing? It's 0. So tangent of 0 is 0. And then it starts going up. Tangent is the slope that my arm is pointing in. Well, that looks like the slope is becoming positive, positive, positive. Oh, at a right angle, it's infinite slope. So that sounds like a vertical asymptote to me. And that right angle is at pi over 2. So, right angle, and then just past the right angle, would you say that's a positive slope or a negative slope? My hand's pointing in. Negative. So it looks like the vertical at the vertical asymptote it changes to negative. It becomes less negative, less negative, less negative until it makes it to 0 at an angle of pi. And, well, maybe let's even see if we can cheat. What's the period of tangent? It's just pi. And maybe if you don't notice that, let's see what happens. So you're at an angle of pi, you keep increasing, that looks like a positive slope. It's pointing into quadrant 3, but positive slope. So positive, 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 oh, it goes to infinity again. At 3 pi over 2. Three pi over 2 comes back up to 0 at 2 pi, and then it's definitely going to repeat because everything on the unit circle is going to repeat every 2 pi radians. All right. There. Sketch the graph of tangent. Done. Is that a one-to-one function? How do you check if a function's one-to-one? Do the horizontal line test. So let's draw a horizontal line. There's a generic horizontal line. How many times does it seem to cross tangent? More than once. In fact, lots of times.
It'll cross a bunch if you keep going.
Yeah, so infinitely many, in fact. Tangent is an infinity to one function. I haven't defined what that means, but if it means anything, this is an example of it. So, is this one-to-one? Well, that's bad. Does this function have an inverse function? No. But you know exactly what I'm going to do next, right? Let's restrict the domain, use as much of it as we can, while it's still one-to-one and without having anything bad happen. So, let's do that, and I'll use pink for that restricted domain. So let's start at 0. So I'm going to go some distance to the right and some distance to the left from 0 and include as much as I can. How far to the right can I go before something bad happens? Pi over 2. And I could keep on going past there and still have it be one-to-one. But then I'd have something weird in the graph of the inverse function. So I'll stop at pi over 2. How far to the left should I go? Negative pi over 2 sounds good. So, restricted to that piece of the graph, would you say that's a one-to-one function now?
Yeah.
Nice, I can invert that. The arctangent function, arctan x or inverse tangent x, or depending on what calculator you're using, you might type it in as atan x, is the inverse to the tangent function after its domain has been restricted to negative pi over 2 to pi over 2. Should I include or exclude those endpoints? But, yeah.
What was the restricted domain?
Yeah, so I am going to restrict to that much of the domain. So let's actually write that down. So I am writing it down right now. So that's negative pi over 2 to pi over 2. Because there's a vertical asymptote here at negative pi over 2. And I'll stop at that vertical asymptote. And there's a vertical asymptote here at pi over 2, so I'll stop at pi over 2.
Thank you.
Yeah! So the domain's been restricted. Pi over 2 and negative pi over 2, are those even in the domain of tangent? Yeah, so I better not include them in the restricted domain. All right, and if I now want to get the graph of inverse tangent, you know exactly what to do next. How do you get the graph of a function from the inverse function? Flip the x and y values. So I'll take the pink piece of that graph, I'll flip the x and y values. So 0, 0 will become 0, 0. This is getting close to x equals pi over 2. So the inverse function will have a horizontal asymptote at y equals pi over 2. These points where it gets negative will become negative and get close to y equals negative pi over 2. Sensible enough? All right. So by looking at that graph, we'll read things from the graph and see if they check out. So what's the domain of that? Negative infinity to infinity. So inverse tangent doesn't have any domain restrictions. The domain of inverse sine is negative 1 to 1. Domain of inverse tangent is everything. If you like to write all real numbers, then write all real numbers. What's its range? Nice. Except you put those in the other order. And exclusive because there's a horizontal asymptote that's never quite reached. People feel pretty good? All right. And I know it says to pull up Desmos, so I'm going to go ahead and do that. So I'm going to have this to the side. We will pull up the Desmos. And I still want like the notes pulled up. I'll make them big again. So, start with the graph of tangent x. That look like what we drew for tangent of x. Nice. Next line, I'm going to restrict the domain following the instructions that we just saw. So, there's tangent of x, where I have restricted x to be between negative pi over 2 and pi over 2. That agree? Yeah, and that's, if you like, also the notation for in Desmos, how you can have a restricted domain. All right, and if I now want to see what happens when you flip the role of x and y, you can just flip the role of x and y. X equals tangent of y. So that graph is looking messy right now. If you were to see that graph, would you say that looks like the graph of a function? No, it fails the vertical line test like really badly. It's really the graph of like infinitely many functions. So you pick one. And how do you pick it? You pick it by find. That looked like what we graphed. Nice. And now you know what? Let's directly graph arctan. Yeah, that looks right.
Why do they choose to use arctan instead of just inverse tangent?
That's a choice that I made. Desmos is flexible.
But
I believe.
in every case, it just means the same thing.
Yep. And the other notation you could use is atan. Oh no, I guess Desmos doesn't like atan. Okay. Today I learned. Feel pretty good? Nice. And if you want to, like, maybe just to see this happen, it matters whether you're in degree or radian mode, right? All those are in radians. If you change to degrees, oh, there's degrees. Oh, notice that looks taller. And if you like, that's just because 1 radian is a significant number of degrees. So now this horizontal asymptote should be at 180 degrees or something? Because that's what pi over 2 radians. Yeah, that should be close to 90 degrees. Oh look, those y values are getting close to 90. That horizontal asymptote should be at negative 90 degrees. Yeah, that checks out. Neato. I'm going to switch back to radian mode now. If I can, this button. Groovy. Folks feeling all right? Nice. So there's the first thing done. We now have one more inverse trig function that we can think about, inverse tangent. Let's remember some domain and range concerns. So let's remember our sine and cosine force. What's the range of inverse sine? Negative pi over 2 to pi over 2. Flip back to a previous page if you need the reminder. And if you like, the reasoning is, one way of getting the reasoning, is what angles starting at 0 can you use for sine and get all the sine values? If you go up to pi over 2, you get to a right angle. Go down to negative pi over 2, you get a negative right angle. Yeah, that achieves all the y values. Negative pi over 2 to pi over 2, inclusive. And what's its domain?
Negative infinity to infinity.
For our inverse sine.
Yeah, -1.
Same game but for cosine. What's the range of inverse cosine?
0 pi included.
0 to pi included. Because if you start at 0, cosine is the x values. What angles do you need to include to get all the x values? So it goes up, you're getting positive x values, and then negative x values, you make it to pi. Oh, and you've gotten all of them now. There's the range of inverse cosine. And its domain is -1 to 1, because those are all of the possible x values for cosine. Inverse tangent is right above. Its range is negative pi over 2 to pi over 2. And its domain is negative infinity to infinity. You can plug anything into inverse tangent. Groovy. All right. Let's do some things. This is mostly just like recalling some things that we'll use in a moment. So let's suppose I wanted you to think about inverse sine of 6/7. Not like computer. To computer, you'd have to use a machine. But how could you draw a picture of that angle? That's right, it is an inverse trig function, so I should think of this as being an angle. Let's try to draw a picture of that angle in a triangle. A right triangle. So there's this angle theta. This angle is the inverse sine of 6/7. So what trig function do you definitely know about this angle?
The hypotenuse and the opposite side.
Nice. You can figure out the hypotenuse and the opposite, because if theta is the inverse sine of 6/7, that means the sine of theta should be 6/7. And that's the job of inverse functions in general. Oh, and if we want to translate that into a triangle, adjacent over hypotenuse. Nope, SOHCAHTOA, opposite over hypotenuse. So I can label the opposite as side length 6, the adjacent as side length 7. Oh, cool. Let's suppose I wanted to, I'm not asking you right now, if I asked you to compute like tangent of this angle, could you? Yeah, you have to compute the adjacent side length using, I guess, the Pythagorean theorem. And then you'd be able to compute tangent. Cool. We'll use this idea quite a bit. Maybe I'll also draw this one other way. So sine in terms of right triangle trigonometry gives you the y value, right? So that means that this point is at an unknown x value and a y value of 6/7. Seem pretty all right? Nice. Think you could figure out that y value? That x value? X squared plus y squared will be 1. So that looks like an equation you could solve for that unknown. Neato. And let's remember like 3 more things. If you start with inverse sine of x and then apply sine to it, what does that give you back? This is the one that's not complicated.
Just sine.
It's just that x value. The sine wants to undo inverse sine. And you can read that off. So that x value starts with like, so inverse sine of x asks you for what angle results in the sine of x. So if you start with an angle whose sine is x, then what is its sine? X. It's like a question whose answer is in the question. Similarly, what's the cosine of the inverse cosine of x? What's the tangent of the inverse tangent of x? Nice. With some domain constraints. Those two have to be on the appropriate domain, because what is the domain of inverse sine? -1 to 1. What's the domain of inverse tangent? Everything. So there's no domain constraint for the last one. All right, so there's like a little bit of new stuff in there, but mostly that was a review of things that we did last time. What my goal today is thinking about mixing trig functions and an inverse trig function. So things that look an awful lot like this, but I'll use a different trig function than the inverse trig function. I want to figure out what things like sine of inverse cosine are. Seem like a fair enough goal? Yeah, so in terms of y, so this is something that comes up with some frequency. You'll see it in calculus a fair amount. When you do techniques that involve trigonometry in calculus, you'll often see these. But these also mean something. Let's think about what that means. So this is, what is inverse cosine? So this is saying if I start with an x value and tell you that I want you to study the angle whose cosine is that x value, then what is the sine of that angle? And that now suddenly sounds like something that you need to do an awful lot. If I ask you for that x value, given that the y value is 6/7, I'm asking you to compute the cosine, because it's an x value, of the inverse sine of 6/7. So whenever you need to translate from a sine to a cosine, you need these formulas. And it turns out we'll get some interesting formulas out of them. Did I read your lip correctly? Did you say y? No?
No,
Okay, well.
but it's a good explanation.
It was a good question. So I'm glad I imagined you asked it. All right, so let's try to do some of these. Let's try to compute. Let's start with this. Cosine of the inverse sine of -3/5. So let's try to do it. So I'll make these computations will be very pictorial. So here's the strategy I'll take. Inverse sine of 3/5. This you should think of as being an angle. 3/5 gives you the output value of sine. Theta is the angle that gives you a sine of -3/5. So I should think of that thing that I underlined in pink and then didn't scroll the screen correctly to show you as being an angle. Let's draw a picture of that angle. So, let's see, if theta is inverse sine of 3/5, then what can you tell me about the sine of theta? What's the sine of the inverse sine of something?
Obviously, we're -0.5.
Awesome, so you gave me both of the answers I wanted. -3/5. That'll be opposite over hypotenuse. Though, like right triangle stuff is always a little bit weird when you see negatives. Because like either I'm going to need to think of the opposite side as being negative or the hypotenuse as being negative. And in order to figure out which, let's think about what quadrant this would be in. So inverse sine can be either in quadrant 1 or quadrant 4. And I want sine to be -3/5. So do I want quadrant 1 or quadrant 4? Quadrant 4, because I need sine to be negative. So this is going to be an angle in quadrant 4. So I guess that means the y value, so like the opposite side is going to be negative. So let's label this triangle. What's the length of the hypotenuse? What's the length of the opposite? -3. And this time the negative means something. The negative means it's pointing down. Its length is just 3. All right. And let's see, SOHCAHTOA, I want cosine of this angle. So that will be adjacent over hypotenuse. I know the hypotenuse. The hypotenuse is 5. Looks like I just need to know the adjacent. What is the adjacent side in this triangle?
4.
I hear a 4? How'd you get the 4?
I did Pythagorean theorem.
Yeah, Pythagorean theorem. Should I do the work of finding that adjacent side length? Cool, let's do it. So, I need to figure out the adjacent side length. Adjacent is maybe a longer variable name than is ideal. You might want to call it x. So, let's find adjacent. Find adj. So by the Pythagorean formula, the adjacent side length squared plus -3 squared should be equal to 5 squared. That look like an equation that you can solve? Yeah. And let's start by just evaluating the things we can evaluate. What's 3 squared? 9. So adjacent squared plus 9 equals 5 squared. All right, you need to solve that? What seems like a good strategy?
Subtract 9 from both sides.
So adjacent squared is 25 minus 9. What's 25 minus 9? 16. All right, and now I need to get adjacent on its own, so how do I do that? Square root. And maybe I'll be like a pedant here. There's like a plus or minus there. And then the square root of 16 is 4. But you said it was positive. Why
Yeah.
positive?
Because it's in the fourth quadrant, so the x has to be positive.
Awesome. Fourth quadrant, the x value is positive. That feel pretty good? Nice. So, the adjacent is 4. So it looks like the cosine of theta, so put that 4 there. Cosine is adjacent over hypotenuse is 4/5. That seem alright? Nice. And, you know what? As long as we're doing things with Desmos, let's do things with Desmos. I don't think I need any of these anymore, but I'll keep them up. So, here's something that you can definitely do using Desmos. I could pre-graph the graph of cosine of arcsine of x. Oh, cool. Looks like the graph is like a semicircle. Interesting. Wonder why that is. Now we can use that to figure out what happens when we plug in x equals -3/5. All right, we get an output value, it seems to be positive, 0.8. Does that agree with the computation we just did? Yeah, cool. All right, just remember, you can use a graph to evaluate functions. You can use a computer-generated graph to evaluate functions. I guess I don't know that that 0.8 it's giving up there is an exact value, but except I do because like I found it. It's 4/5. Cool. That feel pretty good? Think you could do one on your own? So here is one that is more complicated only in no, okay, I'm off schedule. Well, I don't know. No, let's follow the notes. Was there anything special in what happened up there that like made -3/5 like a special number so that this wouldn't work if I plugged in something else? I guess could I have gone through the same process for an input value of 2/7? For 1/pi? For 0.0356789? Yeah, I think so. So let's just try to get a general formula for this. Let's plug in a general value x and see if we can follow these instructions. So let's try to get a general formula for the cosine of the inverse sine of x. And I'll follow the same steps. I'm going to think of that as being an angle. So I'm going to give it a name, like it's an angle, I'll call it theta. So if theta is the inverse sine of x, what can you tell me about the sine of theta? It's x. And I expect a variable to be here. I expect that the cosine of the inverse sine of x isn't going to be the same no matter what you plug in. So I expect x's to have a job. Ooh, so sine of theta is equal to x. That like something I could draw a picture of? Let's draw a picture. So I guess I need to draw a right triangle. SOHCAHTOA. So maybe we'll think of that x as being x/1. So there's an angle. What sides on that triangle could I label?
The opposite, or, yeah, opposite.
Opposite and hypotenuse. How should I label them?
The opposite is x,
Nice?
and then the hypotenuse is
Cool. People feel good about that? All right, and I would like cosine of theta. So I won't even put the 1, let's just give me space down here. So I want to compute cosine of sine inverse of x. But I have a name for this thing, it is theta, so cosine of theta is the thing I want. And what does SOHCAHTOA say about cosine?
adjacent
Adjacent
over
over hypotenuse. So this will be adjacent over hypotenuse. Do I already know either the adjacent or the hypotenuse?
hypotenuse.
I know the hypotenuse. The hypotenuse has length 1. So I just need to find that adjacent side length. Do we have everything we need to find the adjacent side length? Yeah. So let's think about how we found adjacent above. We said, well, I know adjacent squared plus opposite squared is equal to hypotenuse squared. So let's write down that equation. So let's label this as adjacent. I know that adjacent squared plus, what's the side length opposite? X squared equals hypotenuse squared. What's the hypotenuse?
1.
And I need to solve that for adjacent. That look reasonable to solve for adjacent? There will be some x's in your answer, but that's fine. In fact, I'll ask you, should I do the algebra or should I just be quiet? Should I do algebra? Cool, I do the algebra. I guess that means those of you who didn't raise your hands, what would you want to do to that first if you wanted to solve that for adjacent?
Subtract x squared.
Yeah, let's subtract x squared to the other side because I want to get adjacent on this side. And I'm also going to replace 1 squared with 1. It's fewer things to write. Adjacent squared equals 1 minus x squared. And right, the stuff on the right-hand side is complicated, but you expect it to be complicated. What next? Take a square root of both sides. All right. And again, I'm going to be picky and say, well, whenever you take a square root of both sides, you lose this information. All right. So there's a plus or minus that shows up. Plus or minus? Let's think about quadrants to figure that out. What quadrants does inverse sine trace out? What's the range of inverse sine?
1 and 2, or plus
1 and 4.
1 and 4. The range of inverse sine is quadrant 1 and quadrant 4. Range of sine inverse is equal to quadrant 1 and quadrant 4. In quadrant 1 and quadrant 4, the x value is positive or negative? Positive. So this adjacent side will definitely be positive. Even if the opposite side is negative, the adjacent side will always be positive. Ah, square root 1 minus x squared. That seemed pretty good. So that gives us a formula. The cosine of the arcsine of x is always the square root of 1 minus x squared. And this is, of course, not page 1. I'm going to put this on page 150, the previous page. cosine of arc sine of x is always the square root of 1 minus x squared. I just put that on this page under that blank. All right, so here's what I'm gonna do. I'm going to do something to check. What's something you could do to check if this formula seems correct?
22. Correct.
Oh, cool. Yeah, you could definitely plug in some x values. I have Desmos open, I'm gonna look at graphs instead. What you said is totally valid. So, there's cosine of the arc sine of x. Let's also graph the square root of 1 minus x squared. That seemed pretty good? Nice. So here's some interesting stuff to see. Cosine of the inverse sine of x, that looks like something that has to do with lots of geometry and trigonometry. That's something that doesn't. So there's some general thing that you'll see. Whenever you undo a trig function with another trig function, you'll wind up with something purely algebraic. You'll wind up with some algebraic expression, which is nice. Algebraic expressions you can often do useful things with, like solve. All right. We have 8 minutes. So I think here's what I'm going to do with this time. I'm going to, so sine and cosine are really closely related. So the computation we just did, do you think you could do that with sine and cosine reversed? And like, yeah, suddenly you would know the adjacent instead of the opposite, and you would need to find the opposite. But that sounds like walk that's exactly the same as what we just did. And so I'm skipping it not because it's hard, but because I'm down to 7 minutes left. The formula for the sine of the inverse cosine of x is also the square root of 1 minus x squared. Those two things give the exact same formula. What I think I want to emphasize instead with my remaining time is let's not try to extract any more formulas today. Instead, let's try to use these ideas to do one more similar example. Let's try to compute the cosine of the inverse tangent of negative 4 over 5. That seem like a reasonable, does that seem sufficiently similar to what we just did that we can probably use same-ish ideas? Like there's a tangent instead of a sine, but the algebra will be different, but I think the ideas will be the same. So here's how I'll start thinking about it. Negative 4/5 is something being plugged into inverse tangent. Inverse tangent gives you the angle that tangent sends to negative 4/5. So this thing I should think of as being an angle. With me so far? All right. So if theta is the inverse tangent of 4/5, negative 4/5, then what can you tell me about the tangent of theta?
Simply 4 to negative 4.
Yeah, it's just negative 4 over 5. It's the thing inside. All right, let's draw a picture of this, and I'm going to make sure it's in the correct quadrant. What's the range of inverse tangent? Flip back 2 pages if you need to.
Negative pi 2 over pi 2 excluded.
Nice. Range of arctan is negative pi over 2 to pi over 2. What quadrants is that?
4.
Quadrants, well, 1 and 4, but you've combined that with the other information. So this angle is either in quadrant 1 or quadrant 4. And I know that its tangent is negative, so quadrant 1 or quadrant 4. Quadrant 4. Nice. So I have this angle is pointing down into quadrant 4. Cool. All right. Let's draw a triangle. Let's use tangent of theta is negative 4 over 5 to label this triangle. Which sides can I label?
Opposite and adjacent.
Opposite and adjacent. What's the opposite?
Negative 4.
Negative 4. What's the adjacent?
5.
All right. And notice that negative 4 agrees with what we already thought it should be. It's in quadrant 4, the y value should be negative. That points down. And I would like to know cosine of arctan of 4/5. So that means I need cosine of theta. Cosine is adjacent over hypotenuse. So it looks like I need to find the hypotenuse. And we got 4 minutes. I could find the hypotenuse, or I could like be quiet for a little bit and you'll tell me the hypotenuse.
Square root of 41.
I hear root 41. Or yeah, so let's deal with the plus or minus. Should it be plus or minus?
Minus, it's a negative slope.
But it's in the fourth quadrant. So it can-
Yeah, so the slope is negative, but the hypotenuse is still positive.
Oh, I just, yeah.
Yeah, so the hypotenuse is positive, because otherwise the sign would wind up being positive, because you have negative divided by a negative. I want the sign to be negative. So the hypotenuse should wind up being positive. And what did you tell me it was?
Square root of 41.
Root 41. Does that agree with other people who did the computation? Nice. And I'm not going to get a decimal approximation. How many people did get a decimal approximation? I'm not asking you to, I just want to see how many people did. Oh, okay, cool. I wouldn't have either. All right, so I know the hypotenuse now. Is that enough information to figure out cosine?
Yeah.
All right, so what is the cosine of this angle?
Negative 4 over radical. Or, sorry.
Yeah, so
Yeah,
you computed
that's fine, yeah.
sine instead of cosine. So toa, cosine is adjacent over hypotenuse. Adjacent is 5 over the square root of 41, and that's a fine answer, but let's get into the habit of moving square roots to the numerator. 5 root 41 over 41. That process seem pretty okay? Neato. Do you think using these same ideas, I don't have time to do it, do you think we could use the same ideas as we used for the sine of the inverse cosine of x to get cosine of the inverse tangent of x? Yeah, well, like there would be an x over 1, so you could label some sides. Sales pitch, extra credit. Find formulas for cosine of inverse tangent and the sine of inverse tangent. Walk that out, come by my office, talk me through what you get, and you can also check if you have the right answer here. There's a discussion of this, in fact, in the textbook. These formulas are in the textbook. So you can see if you have the right answer, then come talk to me. Neato. Yeah, I'll see you up in my office to just grab a copy of the notes. Sorry, I didn't have it today.